going to write the rule of a function given a table. So before we had to fill in the tables after being given the rule, this time we're going to go in reverse. This one's a little bit trickier, but we're still going to figure it out. So here we have 3 different examples of functions, okay? 1, 2, and 3. We're going to do it for each one of those. But what we're going to need first is to kind of come down here and read about these strategies. So number 1, we want to focus again on the connection between the input and the output. Okay, a lot of times we focus on how the output is changing, which is important, but rather than thinking about the numbers of how the output is changing, you want to kind of think about how it changes in regards to the input. You want to look for a connection with the input and the output. Number 2, we want to look to see if the output is changing at a constant rate. Okay, remember, if it's a constant rate, it's going to be linear. So a linear function is one that just has a regular x involved in it. Okay, there's no exponents or anything involved. If it is not changing at that constant rate, so it like increases and then decreases, or if it like grows slow and then more quickly, or vice versa, you should probably try to use some exponents and see if there's anything you can use with that to figure out your function rule. Last but not least, we want to make sure we're paying attention to how the input values change as well as the output. So a lot of times your output values are going to just like increase by 1 every time, which is the easiest situation. But sometimes they are not going to increase by 1 every single time. You have to be careful and watch that as well. So then hopping back up here, let's take a look at this first example. Okay, this guy over here. We've got our input x, okay, going from 0, 1, 2, 3, and 4. And our output, f of x, going 4, 5, 6, 7, 8. Okay, so again, we want to look for a connection between the input and the output paired with it. So what do you notice about 0 and 4? Like, what could be a connection there? Well, one connection might be, well, we could add 4. So let's check that out. Plus 4 would give us 4 from 0. Does that work with the rest of the table? Well, if we add 1 plus 4, do we get 5? Yeah, so far so good. Keep on going. 2 plus 4 is going to give us 6. Yep. 3 plus 4 will give us 7. So we're looking pretty good so far. 4 plus 4 will give us 8. So that's good. So we kind of found that one pretty quickly. All we need to do simply is add 4 to our input. So again, how would you write that as a function rule then? Well, if x is your input, we have that, and then we just want to add 4 to it. So your rule is simply x plus 4. All right, let's take a look at our next one here. So this time, we're starting with -2, and we're going up by 1 again for our input. And then we've got 4, 1, 0, then back to 1 and 4 for our output. So that's a little bit funky. Notice that from 4 to 1, well, from here to here, that goes down by 3 units. And then 1 to 0, well, that goes down by 1. And then 0 to 1, that goes up by 1. And then 1 to 4 goes up by 3. So this one is that example of something that's not linear. It doesn't change by the same amount every time in your output. So that's where we want to maybe look at some exponents. So like your exponents would be like maybe doing the input squared or the input cubed or something like that. So let's take a look at our input squared. If I square 2, is that going to get me 4? Yeah. I'm sorry, I should have said -2. But yes, if you square -2, that'll give you 4, so that's good. What if I square -1? Yep, that's going to give me +1. So that's good. What if you square 0? 0 times 0? Yep, going to give you 0. Squaring the 1, 1 times 1 again, yes, is going to give you 1. and then 2 squared is going to give you 4. So that one works. So that one is just going to be x squared. We're taking whatever our input is, and we are simply squaring it. Okay, let's look at this last one here. All right, so let's take a look again. Well, between 2 and 22, well, let's see, we could multiply by 11. That would give us 22, right? Does that work for the rest? 4 times 11, 42? Nope, not gonna work. So multiplying by 11 doesn't work, so we can go ahead and get rid of that. But that was a good idea. What else? What else could we try? Well, 2 plus 20 would give us 22. So will that work with the rest of the group there? 4 plus 20, nope, not going to get us 42. So again, that one didn't work. So what else could we look at? Well, maybe we should figure out first, is this going to be linear or nonlinear? So let's take a look at our outputs for a second. From 22 to 42, we're going up by 20, right? Okay. And then 42 to 62, we're also going up by 20. 62 to 82, yep, going up by 20. And last but not least, 82 to 102, yes, going to go up by 20. So that's good news because that tells us that this is linear. So it's going to be something with just an x. We just have to figure out what goes with it. So one thing you want to look at again, remember too, you want to look at your inputs. Do we go up by the same amount every time? Yep, but this time instead of going up by 1s, we're going up by 2. So we have to be a little bit careful with that. So one thing you want to look at is thinking about the change in the y's, or I'm sorry, your outputs, your f of x's. Remember, these guys are equal to y. Versus the change in your input, the change in the x value. So let's come up here and write that. And this little triangle guy, that means delta, or that's the letter delta. That's how you say it. And what that means is just change. If you've never seen that before, you might have seen it in science. So what we want to think about is the change in our output, the change in the y's, versus the change in our x's, the changes in our input. That's going to give you kind of like the rate at which you're changing, and that's going to be that number that goes in front of your input variable. So that's going to be our rate, and that's going to be the number that goes in front of our x. So really what that's finding is how much is your y changing every time your x changes by 1. So that's why it goes in front of the x. It's like the y changes per x change. So every time we're going up by 20, so that's our change in the y. How much are we going up in our x's? We're going up by 2. So the change in y over our change in x, well, change in y was 20. Change in x was 2. 20 divided by 2 is going to give you 10. So we want to multiply our input by 10. So 10 times x. And then we need to figure out, is that it or is there another piece to it? Well, if I do 2 multiplied by 10, well, that's only going to get me to 20. So what else would I have to add on after that? Well, I could do add 2. So maybe let's take a look and see if that works for the rest. If I do 4 times 10, that gives me 40. And then plus 2. Yep, that's going to give me 42. Keep on going. 6 times 10 gives me 60. And then plus 2 is going to give me 62. 8 times 10 gives me 80. plus 2 gives me 82, so we're looking pretty good. Last but not least, 10 times 10 gives you 100, and then plus 2 will give you 102. So that's what our function is going to need to be. We have our 10x, and then after that we just have to tag on a plus 2. All right, so hopefully you can kind of figure that out. Sometimes you won't have to do quite so much work, and you can kind of just think about what the change is between your x's and your y's, your inputs and your outputs, and just be able to write the equation. But just keep in mind these strategies over here, okay? They will help you out. Whoops, somehow it got switched to the other page. But yeah, those strategies are going to help you. So make sure you keep those in mind. All right, ask questions if you need it. Otherwise, move on to the next one, which is going to be writing it based on a graph.